WarsawJS.
The timer. So, do you remember, like 4 years ago, so in like internet years, it's like 200 years at least, there was a TypeScript 4.1, and it was a minor release, but Microsoft, they love shipping huge stuff in the minor releases, like Mind new TypeScript 5.5. And in that release, they've shipped the template literal types. And what is it? Right? By the book. They are types built on the string literal types, and they have the ability to expand into the many strings by unions. At least that's what the documentation says. And they have the very same syntax as the template literal strings in JavaScript, but they are used as types. At least that's what the official docs says. We'll dive a bit deeper than the official docs today. And if you recall, if you're that 200 years, internet years old, and you recall the introduction, they put this ordinary hello world in the first announcement, which says like nothing. But the very next day, maybe even the same day, someone published, I think it was Tomek Sułkowski, he published that example, how you can type the Tailwind classes. If you're using Tailwind, I am, someone? Great. I guess that you know this combination of color and the variant. So, actually, why not type it, right? We know that there is some set of colors, like in my case, gray, red, yellow, green, some set of variants. So, the whole set of possibilities is combination of all the colors and all the variants. So, let's just write a type in the very same syntax as string literal types, with the dollar signs and so on. And voila, here we have it. The union type, which is combination of all of the possibilities from those two types, those two unions. And now this very string, it's not a magic string anymore. It's a fully typed and type-safe value, right? Which has to fit this union. Okay, so that was the very base example, but how we can actually use it? Imagine you're creating the design system, and you have the same base colors and variants, and you're making some button. Okay. It has some probes, it has the color, which is the same combination as we saw. It has the background color, same combination as we saw, so fixed types are only available there. There is some spacing, some framing, which is also some set, or at least it requires some suffix like pixel or one of the other popular units, which you might recall. And let's use it in our fancy design system. Nothing interesting here. The usage is more interesting. That both, they have those magic strings, or at least that's how they would behave in JavaScript, for example, or with TypeScript, but without the template literal types that we've used. And the very first example, it just won't compile. The very blue please, no matter how much we'll please, it won't work. Not the green 400 as it will. So, a pretty few interesting examples were created just after the release. Pretty odd ones, like the Eliza bot. It's a conversation bot from the 60s, Eliza, where you can just put here a message to the Eliza and get some response fully on the type level. Tell me a joke. Tell me a joke. Yeah. Not quite works, but if you take a look at the implementation here, it's just a bunch of ifs underneath, right? Just a bunch of ifs, a lot of infers, and tons of the template literal types. Really great example, but not very useful. Yet another great, but not very useful. Back in the days, it was 100 internet years ago, because it was 2 years ago. Orta from the TypeScript team, he recreated the Wordle, the popular word game back in the days, on the type level. Also nice, but not very usable. And the famous TS SQL is my absolutely favorite example made purely for fun, where you can have the SQL engine purely on type level. Why? Because you can. This is the only reasoning. And yeah, it really works. Yeah, I won't play with that because I don't have time. But if you're interested, in the end of my presentation, I have the QR code with the whole slides and the links, including all of those examples. They are linked here on the slides. So yeah, nice one, but also not very useful. But we had some useful examples which were like done not that far away after the initial presentation of this feature, like from Hasura, which solved the problem of magic strings. If you ever use Hasura, they are supporting multiple database engines. And for each engine, there is a different set of features or commands which can be used. And before that, you have to just know which are available. But after the template literal types drop in and they've used it, they could actually type save all of those strings more in their block. Or something else very useful, which is Kisly, the SQL query builder, which is also not using just the magic strings, but actually a fully typed strings based on some schema which you have to define upfront. Works as well like a charm. And the really cool feature, which is still experimental in Next.js, which are statically typed links. So if you try to put href into link, which is not in your file hierarchy and which won't resolve in the page, it just won't compile. We'll get back to it later. And this is me. My name is Michał Michalczuk. I live in Gdańsk, but I'm working for Tech Consulting, a small Berlin-based consulting agency. I'm also a talking head at Just Join It. I'm doing various video and audio formats with them from time to time. But let's get back to the template literal types, where we can use them in our applications, how we can leverage it. At the end of the day, they are just types which should help us. So imagine this case. You're creating some app which includes setting up a server, setting up a service. It has the name, it has the address in IP version 4. So we know the format of IP version 4. Those will be 4 numbers, okay, 8 bits numbers, but for simplicity, those 4 numbers separated by the dot, right? We can type it with a template literal type. And now it will force us to put a correct value here, right? So if you're making the configuration in the code, it will guard you to not put any gibberish there. If we would like to expand our config with any option by the convention, so yada yada anything option, let's create some map type which will force to use the option suffix, and the value have to be Boolean. So that one will just work dynamically, right? And if something doesn't have the option, it just won't compile, right? All thanks to this. So making things by the convention is, in my opinion, one of the good usages for the template literal types. Okay. Anything else? I guess that you know the discriminated union types. So the pattern where you have the one field which is unique per type. Like here, I have a success and a failure, and they both have the unique field called type, which is the discriminator. So to dispatch them, right? To dispatch them, I can just put switch here or bunch of ifs, and with the template literal types put as here, anything which ends with the success will be treated as a success, and anything with the XX error will be treated as an error. So yet another cool thing, how you can make your code base more flexible, especially if you have something which is older. And let's take a look at it from the a bit different side and have something which is a kind of dynamic in return. So imagine that you're creating this, this type, and let's use the template result type as a result type, right? So it will result in anything with a success in the end. But let's make it more robust and fix it to the HTTP success or process success. It's still pretty like limited, and you have to put a lot of manual effort to expand it. But with the TypeScript 5.0 const type parameters, you can do really cool things, in my opinion, like that. That if I'll put here a param, which will be of a type T, the generic type, and then I will say that, hey, this is actually a const, it will fix me the result type to just IO success, right? So it will narrow down pretty dynamically to this generic type. Really nice one. And why actually to use it? To reflect the reality, because existing types, they can be pretty messy. So fight with the mess. And what about the map types? We saw one example, but in general, here comes the fun part. Did you miss Angular? Who's using Angular? Anyone? Okay, don't be shy. I used to work with Angular a lot. I really like it. I kind of miss it. But imagine that you're creating the system. You have the users, as we all do. I hope so. And the user has the name, surname, and the age. And you would like to create the handlers for those. So for all of the fields, we should have the output, so the event emitter field with the suffix changed. Cool. Let's use map types and create field per each field, yeah, in the given type, plus the changed suffix with that. And right, and we got it. And now we will be forced to implement both of the inputs and the outputs. So one more time, making things force the things by the convention. It's a good usage for the template literal types here. Okay, now let's do the opposite. Imagine you have the existing code base and you would like to take only those handlers. Can you do it? I'm not interested in the name, surname, and age, but all of those changed stuff. I can, why not? There is a built-in helper, pick. So let me just pick from the user anything which matches this predicate of any string and then changed. And is, by the way, a key of user. And yep. Why? One more time, why do we need it? If you're surfing over the legacy code base and you just don't want to repeat the types and type it over and over again, good way to reuse it. And this is something which I'm actually using in my project, so it's not just a dummy TSQL example. Okay, let's dive more into the topic. If you ever had a chance to work with any finance project or maybe something which includes the medical data, I had this chance. You have to store any freaking change. If you're changing the visit, you're storing the change. If you're changing the patient data, doctor data, invoice, bill, literally anything, you have to store it. So in your system, you probably have a lot of change log or change log tables, history tables, and so on. So for the patient, we will have the all of the fields with old and new values. For example, that's just one way to do it. And okay, let's just write it once and forget. But then it spawns over your system. Like actually, every freaking table needs its sibling with the changelog. So we're lazy. Let's use our superpower, the laziness. And let's write down the helper for that. So we have the patient entity, name, birth date, sex, and our helper, the changelog, which will have some fixed sets of its own fields, plus for each given field from the given type, from the T-type, we will create not one, but actually pair of fields, so with old and new prefix. Why? Because here I just put the union, so it will have to create like actually both. And don't trust me, trust the code. It will just generate the type for me, right? So effortless. I can just do it with the small little type helper. Okay, so some time was saved. But what else we can do with those template literal types feature? We saw how to generate it, but now how to, I would call, unpack it. At some point, I was working at Atlassian in ecosystem organization, and we were using the ARI, which is the Atlassian Resource Identifier. If you're using AWS, there is something like ARN, Amazon Resource Name, something like that. Similar idea. This is the hierarchical identifier. And as you see, it has the ARI, then there is a cloud or server, then there is a resource owner, cloud ID, resource type, yada, yada, yada. It's a hierarchy. And you can read any part of this hierarchy depending on the part of the system that you're currently working on. If you're only interested in who's the owner, you're just picking that owner part from the string. So there is a pattern. And let's type this pattern in types, right? Resource, owner, environment, they are fixed sets of possibilities. If I'll create a template literal type for that, right? I can just write this pattern as a plain type. And it will be, of course, combination of all of those possibilities, and it will just type guard with me playing with those strings. Does it make sense? Yes, if you're making your configuration from the code level. Of course, it will just guard you. And so we can create it, but imagine that we would like to unpack it. Why? Because it might not be your type. It can be part of some external, package, some dependency. It's just not yours. But you would like to use only the environment or only the owner part. Hey, we have the infer. Let's play with it. We know that on the first position after the ARI column, there is an environment. So I can unpack it, right? And I will know that it is cloud or server, so I can now use it in my own code. Come on, I need the owner? Yeah, sure. I know the owner is on the second position. Let me just infer that part, and I will know that this is the owner. And so on, and so on. Don't trust me, trust the code, right? I can do it as well. I can also go wild and unpack all, just put as many infers as possible here and have the more object style here, which can be also pretty helpful if you're making some code configuration convention. Why not, right? So I would call it unpacking. And one more time, why do we actually need it? Because it might not be our code base, but something which we would like to reuse from someone else's code and use it in our components and so on. Okay, and remember one thing, TypeScript is not a new language anymore. It's like 11 years old. In this year, it will be 12. I'm using it since 2013, and I saw a lot of stuff, a lot of evolutions here. And there are a lot of legacy patterns existing. Like that one, imagine that someone 100 internet years ago created those two types, success and failure. And now we would like to know what the heck happened and where the failure occurred. Was it the HTTP failure? Was it the pipe, process, file? Yeah. So let me unpack it one more time. So those are the two types that you just saw. Let me create some small union. And now, with the magic of infer, it's not magic, by the way, just with the infer, let me just take all of the fields named type, which extends something, which we will infer, and then success or error. And we got it, right? We don't have to type it again. We can just reuse the type. We can actually parse it from the previously existing types. So pretty cool one. Okay, have you missed Express? I don't, but probably you recognize that one, that Express have those path params. So yeah, of course that you can unpack it, right? Why not with the same patterns? You can do some recursion inside. Don't do this at home. And if you would like to complicate your life even more, there is a library for that, which is called HotScript, which means higher order TypeScript, because why not? Don't do this at home, but you can actually unpack it even more with adding the types and so on. Crazy things. But I'm running out of time, and I guess that you're curious how then Next.js statically typed links works. So I've created a small app. This is those are the folders in my application, some posts and some comments. I've turned on the typed roots experimental flag. Sorry. And this is the result. If I'm linking to a resource which matches those files, those pages, it works perfectly. But if I'm trying to link to users or posts which doesn't match the path, it will just break. And I was wondering how it happens underneath. Like, they cannot read the files and link it with the compiler, and with the language service, it wouldn't make any sense. And I was right. It wouldn't make any sense. On the build, or during the dev build, they are just generating the files with the types. And by reading the directories and files, and by the convention, of course, they are just creating all of those roots as a types, and then the href is just type of route implementation. So pretty clever, I would say. This is a really good one. So TypeScript, yeah, you can think about it like a big autocomplete plugin. Yes, and you will be very right about that. But of course, there is a limit to everything. And let's revisit this configuration example. And actually, now let's force user that, hey, here we can have only 8 bits, some number from 0 to 255 on each position. Will it work? OK. How I did it, this is the small type helper. It has the recursion inside. So actually, it hits the limit. Because it exceeds the 100,000 combinations, which is the limit for TypeScript. And the calculations, in general, they are very, very CPU consuming. So there is a limit. And I have 2 minutes? OK, I will do it. And in general, TypeScript team, they recommend that people use ahead of time generation for the large string unions, like that one. But for smaller cases, just use it. Just use template literal types. This is really cool feature which will help you. And when overused, they will just give your IDE hard time because they will just be complex, use the CPU, especially while combined with recursion, as my example. Also, they will give you, future you, and other maintainers a lot of pain, probably, if they will try to understand what the heck happened there. Small appendix, if you would like to check the performance of the compiler, you can. I have the slide on my presentation, so sorry. And in general, this is really a wrap-up. So use TypeScript-rich types toolset. Don't make your types look like a Git conflict, please. Then, if they do, please do a step back. And type them all, but please be rational and remember that other humans will have to read it, including future you. And thank you very much.
No problem. Hey, thanks for the presentation. My question is, what about the readability? If you have a union of very many types, TypeScript says, and etc. more. Is there a usable way to see all the combinations if one wants to? You showed an example where there was literally all the variants combined, and you showed how to extract things from that. But I wonder if we prepare a type that is fairly complex, someone may have problems reading it and imagining what are the combinations. Is there a tool to help in such a case? Thank you.
I'm not 100% sure. For sure, there is a compiler flag which will show you the whole error content because the errors are also trimmed. There is a Visual Studio Code extension from Matt Pocock called blah, 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 something TypeScript. You'll find it. Blah, blah, blah. Yada TypeScript. I guess that you'll find it, which also helps with the errors. But I'm not sure will it show all of the possible unions.
You don't have a case that you can really decide.
Hi, so why to bother and not use any everywhere?
Ooh, that's a tough one. That's a tough one. Why not just use JavaScript? Like, with any, you're just on the JavaScript level of typing. Yeah, it just won't help you with anything.
Maybe some additional question about these fun projects that use TypeScript as they shouldn't, like DB. I heard that first time from you, so that I'm interested if maybe there are some other fun projects like that that you know of.
I don't recall the most odd ones I put in here in this presentation. By the way, there is one odd project which gives you opportunity to use regex in the types, but it is very far from being performance, so don't use it. Don't even Google it. But there is
Just
a
forget he
project like
mentioned that.
that.
He didn't even say that. Everyone, please give Michał Michalczuk a big hand. Thank you.